Okay, so AD is a side in this top triangle, right? Which is a non-right angle triangle. So here we're going to have to use sine or cos rule to find AD. But if you're looking at everything in blue, that's what was given. All right, we didn't actually have enough information in this outer triangle to find AD straight away. We had to work in the right angle triangle first, because that is the triangle in which we had enough information to actually calculate that side, right? So this is a right angle triangle, so we can use sine, cos, or tan. So let's look. If we have this 35 degrees, we have the adjacent side, and AC, the common side, is the hypotenuse. So then you need to ask yourself which trig ratio works with adjacent and hypotenuse. It's cos, right? So cos 35 is 150 over AC. Then you multiply the AC out and you divide. And you get an answer for AC, all right? Which you will have to save in your calculator. We'll just use the answer button for you. Thank you with the answer. Okay, are we fine with that? Finding AC. Guys, it's like what I told you to do. Find the common side, all right, between the two triangles, AC. So even if you don't know how that's going to help you, at least find that side somehow, because you'll get a mark for that. Yes. Oh, sorry, no, it's not angle sum and triangle. It's angles on a straight line. Yes, sorry about that. Okay, so that is the next thing now. If we just ignore that 130 quickly, now we're looking at what we have in the triangle, right? So we are wanting to find AD. We have two sides and no angles. All right, so then I say to myself, if I find that angle there, the included angle, I can use cos rule, right? And it was actually possible to find the included angle if you use angles on a straight line. I just wrote the wrong reason there. I'll fix it now. So you do 180 minus those two, and you'll get 130 degrees. And then you can use cos rule in this triangle, right? Because you can use cos rule to find a side if you have the other two sides and the angle opposite the side that you're trying to find. All right, so that is what I did there. I just couldn't fit my cos in on that line, sorry. It's supposed to be there on the side. You don't have to write that step there. You can just go straight from AD squared equals all of this to the final answer. Let me just fix that quickly. All right, any questions on this one, guys? Were you able to do it? Does it make sense now that you see the answer? All right, number 2. Now, number 2 was a weird question because they didn't have a right angle triangle and a non-right. Can you guys just listen, please? They didn't have a right angle triangle and a non-right angle triangle next to each other, like they have had in all the previous ones. What they have here is actually 2 right angle triangles and then a bigger non-right angle triangle, right? Which I'm not sure if you guys would have noticed that or would have thought to work with that. There might have been a different way in which you could have gotten to the answer, but I'll just quickly explain my method. Then we can look at possible alternative options. So they gave us that angle, this is a 90-degree angle, that is 50. Okay, we need to find AD. Now guys, 50 is this whole length. All right, we don't know what proportion of 50 each of these parts are. So I can't just say, oh, that's 25 and that's 25 and then work with that. Okay, when would I have been able to say that? Yes. Yes, so what would tell me that it is? If it's an isosceles triangle. So guys, if this bigger triangle ABC was isosceles, right? If these two sides are equal, or if these two angles are equal, then if you have a perpendicular line from the top vertex, then that would bisect the base. Okay, so in that case, you could say, so say they told you that this is 32 and that's 32. Then you could say, okay, that means that this line, no, I just didn't draw it properly. It looks like it's cutting it in half on my picture, but it's not actually. All right, but if those two angles were equal, then you could say that this line must then cut that 50 meters in half. But we don't know what this length is. We don't know what that length is. We need to find AD. So what I decided to do was to work in this bigger triangle, right? Because we actually have a side of that triangle. So we have some options, all right? If we have a side in a triangle, we can actually work in that triangle. I have a side of the bigger triangle. So I decided to find AB using sine rule, all right? Because if I have this 50, I can easily find that 93 degrees by just minusing those two from 180, right? If we're working in this big triangle here. So that's 93 degrees. So I have a pair there. And then if I have this 55, I can find the opposite side, right? Using sine rule. So I say that AB over sine of 55 is 50 over sine of 93. Right? Does that make sense? To get AB, I moved my sine 55 to the other side and I got my answer. So there I now have that outer side, which, guys, in a sense is actually a common side if you're looking at the big non-right angle triangle and this right angle triangle here, right? AB is actually a common side there. So then once I had that, I just asked myself, which one am I trying to find? I have this angle, I'm trying to find the opposite side, and I just calculated the hypotenuse. Opposite and hypotenuse is sine. All right, so sine of 32 is AD over 41. There we go. And then you must just multiply the 41 on the other side, and then you can get your answer. Was there another way in which I could have done this instead of finding AB? Could I have found AC instead and worked in this right angle triangle here? Right? We have the opposite angle to AC, so we can say AC over sine 32 is 50 over sine 93. Then we could work out AC here instead of AB. Right? Then you would use that calculation with sine here, sine 55. Yeah, and you would get the same answer. If you did that and you didn't get the right answer, you can just ask me and I'll check your work for you. All right, so guys, and that's another thing that you need to be on the lookout for. Sometimes multiple triangles can make up a bigger triangle. All right, so that's just something there to be aware of. Okay, number 3. There was a lot going on in number 3, and I tried to find the shortest way of doing it, but there might be a shorter method. Did anyone else get 5,78 meters for BC? Yes, okay. Very few people, but okay, we have some hands there. All right, BC was 5,78. Guys, there's a lot going on there. We have 1, 2, 3, then also kind of 4, and then also like 5 triangles, right? So you could have done a lot of different things there in order to get to the answer. Okay, but if your answer is not 5,78, then you went wrong somewhere. Okay, so you'll have to try and figure out what you did wrong. It could also be something as simple as rounding a value off and working with the rounded value instead of the unrounded value. Okay, if your answer is very close to this, then that's probably what happened. You rounded off too quickly. I will give you just a minute or so to copy this down if you got this wrong, and then I'm going to go through it step by step. Yes. You can ask me now, it's fine. Okay, no problem. Okay, just copy that down if you weren't able to do it or if you got it wrong.
With number 1, I worked it out with the sine equation, but I ended up getting something different. But I don't know if that's my calculation error or.
Okay, let me see quickly. Just okay, I think Edgar is blocking his view there. Okay, so BAC.
I worked it out with.
Is the pink what was given?
Yes, yes.
Okay,
so
that's fine. So that's 55, yes. And then AC over sine 90, which is just 1, is equal to 150 over sine 55.
So I don't know.
So then you got that AC is this, which is what I also got.
Oh, did you get that?
So that's correct, yeah. Then ACD is 130, which is what I also got.
No, I think I did.
And then this.
So
it must have just been something here.
Okay. I did it in a They didn't get the other side like.
300 squared. Yeah, it's fine. So you used sine rule where I just used cos, but it's the same answer. It's
Okay.
fine. Yeah, it's fine. Oh, it's slightly different.
Oh, you see, that's yeah, that's
It's
why.
7.
Yeah, so that's why I didn't know if it was maybe it was my calculator or my calculations, or whether it was maybe with the
So it was 150 over sine 55. No, you're supposed to get the same answer.
Yeah,
Sine
so I
55.
figured.
Yeah, you must have just written it down wrong.
Yeah,
Because
'cause
see,
I also had a problem
it's
with the
all the
calculator.
same. It's all the same except for
Okay.
that 7 there. So I
Okay, so that
think
would
you
have
probably
affected
just
my-
copied it down wrong,
Okay.
yeah. Because then here you would have used that.
But you can use sine rule where you.
Yes.
Okay.
Yeah.
Okay. Just wanted to check.
Okay. Ooh, 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 ooh. Sorry.
No, it's okay.
Okay, guys, can we talk about 3? Sorry, that was very loud. Yo. Okay. All right. Let's focus, please. Let's focus. Thank you. Thank you. Thank you. Okay, guys, what I did, again, there were many other things that you could have done, but let's just see if you can follow my reasoning, my logic. And if you did it in a different way, you got the answers, then don't even worry. Okay, so what I did was everything in blue is what was given, everything in black is what I calculated. So the very first thing that I calculated was I saw that they gave me this whole angle A is 40 and the bottom part of angle A is 12. So I just thought, okay, let's just work out the top one, all right? Because if the whole one is 40 and that one is 12, then the other part is going to be 40 minus 12, right? Which is 28 degrees. You don't have to write the reason for that, okay? That is just an angle minus a part of it. There's no like geometrical reason for that. So you could have just done that calculation, or we find with this 28 degrees, okay? Then, obviously, sorry, I should have started by saying we're trying to find BC, all right? And BC is a side of this triangle here. So that's usually where I start, guys. I look at what side they're asking me to find, and I identify the triangle that that side is in. Then we need to try and get as much information in that triangle as possible. All right, so you're kind of working your way towards this triangle. So this is the one that I want to try and find some values for. So if that was, let me just check what I did after that. The 37. Okay, so when I got this 28 degree, I thought to myself, maybe I can work in this triangle here to get that side, right? Because this is a side in triangle BCT, which is the one that I'm trying to get a side of. So maybe I can get that common side there. So then I asked myself, if I want to use sine rule to find this one, I have the opposite angle, which is nice. But then I didn't have another pair of a side and an angle, right? I only had this 8 meters. So that means that I need to find that angle there. Now you could have found this angle in a longer way. I used exterior angle of a triangle. Did you guys notice that this 65 degree angle over here is an exterior angle of this outer triangle? Right? Do we see that? 65 is an exterior angle of this triangle. And we spoke about exterior angles the other day. I can't remember if it was Friday. But the exterior angle is equal to the sum of the opposite interior angles. So if that one is 28, that one has to be 37, right? You take the exterior angle, you minus the interior angle that you have, that will give you the other interior angle. Okay, so that's what I did to get that 37. But guys, you could have done it in a slightly longer way. You could have found that angle there using angles on a straight line and then done angle, sum, and triangle in the whole thing to get 37. That's fine. Just takes a bit longer, but it's all right. Okay, so we need that 37. Then I used sine rule. So then I said BT over sine of the opposite angle is equal to 8 over sine of the opposite angle. I moved my sine 28. I got my value for BT, that side there. All right, now at least I have a side in this triangle. Okay. Then I looked at what do I now still need? I didn't have that yet. So I want to find BC. I have the opposite angle. But then if I have that side, I need that angle as well in order to use sine rule. Right? Remember, we're trying to find BC. So BC over sine of 65 would equal 6,24 over sine of this angle. So then I started trying to find this angle because that is the other thing that I'm needing. All right, now again, I used exterior angle, guys. You could have done it in a longer way, it's fine. But let's see if we can identify exterior angles. That will actually make your work shorter. All right. Do we see that this angle is an exterior angle of this one, this triangle? Just check this bottom triangle. That angle there is an exterior angle of this one. And we have the opposite interior angles. We have 90 and we have 12. So if I add those two together, it should give me the exterior angle, which is 102. That's what I did there. And then I could finally use sine rule in this triangle BTC. All right, so like I said, guys, if you did this in a different way, that's fine. If you got to the correct answer, 100%, well done. Just make sure that you are writing reasons down as well, guys. If you're using angle sum in a triangle, angle sum in triangle, you have to write that. If you're using exterior angle, you have to write that. If you're using angles on a straight line, you have to write those down, okay? So it's not actually just about getting to the answer. You also have to write down everything that you're calculating and the correct reasons next to it. Are there any questions on this one? Okay, guys, we are going to do some examples now. Just get this textbook out here. Can't remember reading now. All right, let's copy this down. Thank you. Application of triangle rules to do proofs. And guys, I'm actually going to do a question from exercise 7. I will draw it as well, but just write it down. Exercise 7, page 226. I'm going to do the first one, and then you guys are going to do the next, not the rest of it, but the next few questions. Okay, I'm going to write the question down as well because you might not have your textbook here. So it says, show that D is equal to, and then it's a fraction sorry. This is an alpha, so it's like that fish plus beta in the brackets. Like that little fish shape that you do. All right, and that is the picture there. All right, let's go. We're ready? Okay. Thank you. Let's focus, please, guys. All right, this question is saying, show that D is equal to this whole thing. All right, now D is this side over here. So basically, guys, what we need to do is we actually need to find an expression for that side, for D. And in the end, the expression is supposed to be this. All right, they're basically telling us what D is equal to, but we must still find it in the normal way. Right? They could have just said, find an expression for D. That could have been the question. We are going to have to do the exact same thing. They're just telling us what the answer is already. Okay. So we're not actually going to use this in our calculations. We are proving this. This is what we want our answer to be. Okay, they've actually given us the answer. But guys, we are not allowed to use this. They're saying that we must show that it's true. So we can't use this in our actual calculation. Let's write that there because that's very important. Guys, if you use this at all, you get a 0 straight away. They call that a breakdown. Okay, even in matric finals. So let's just make a little note there. This is the answer. We may not use this in our calculations. So it's almost like when we were proving identities, right? We wrote left-hand side is equal to, then we only worked on the left-hand side and we got it to be equal to the right-hand side. It's a similar thing here. We're only going to try and find a value for D, or an expression rather, and we need to get it to be equal to that in the end. Okay. Now guys, D is this side over here. I've tried to make it a bit thicker with my pen. Just do something there, highlight it or something so that you know that that is what we are trying to find. That side there, BD. Now we don't have any values. We only have that 90-degree angle there, all right? But they didn't give us any length of sides as in numerical length. They didn't give us numerical angles. We need to work with all of these symbols all the way through. Okay, so you need to be very careful when you're working with these things. Just like in the previous questions, they have given us more information up here than down here, in a sense. This top triangle is a right angle triangle, right? So I can work with sine, cos, or tan, or Pythagoras if I have enough information here. This bottom triangle is a non-right angle triangle. So here I'm going to have to work with sine rule or cos rule. Okay. Now guys, what is the common side between these two triangles? BC. So that's what I'm going to do first. I'm going to write an expression, find an expression for BC. I'm just going to write that as a little note. Just add it there. You'll obviously not write this down when you're actually doing this in a test or exam, but just that's our first step. Find an expression for the common side BC. So let's look in the top triangle there. We have an angle theta. We have the opposite side to that angle, right? Opposite. What is BC in relation to angle theta? It is the adjacent side. Now, which trig ratio works with opposite and adjacent? Tan. So I can say that tan theta will be equal to K over BC, right? So tan theta is equal to K over BC. How do I get BC on its own there? What must I do first? Multiply it out. All right, it's in the denominator. I don't want it there. So we're going to multiply it out here. We're going to say BC tan theta is equal to K. So what is BC then? K over tan theta, right? I'm going to divide by tan theta. So BC is equal to K over tan theta. Can I get a value from that? No, I don't know what K is. I don't know what theta is. All right. So in the previous questions, when they gave us specific values, we could actually find the length of BC and work with that value in the bottom triangle. I can't find the exact length now. I have an expression for the length. All right. Which means that now when I'm going to sub in where I would normally sub in this length, I'm going to have to sub in this whole fraction. Okay, but we'll do that later. So that's the first step done. We found an expression for the common side. Guys, if you don't know where to go from there, you at least, I think we'll have 2 marks at that point. All right, they should give you a mark for that and then a mark for getting BC on its own. So with these questions, if you don't know where to start, you really don't know what to do, just find the common side. All right, and if you don't do anything after that, it's unfortunate, but you will at least not get 0 for the question. Okay, now I need to work in this triangle here at the bottom. It's a non-right angle triangle, so I either need to use sine rule or cos rule. We're trying to find D, guys, so this is the side that we're trying to find. I usually check for sine rule first. Okay, let's see if I can use sine rule. D is D over sine of the opposite angle. I do have the opposite angle, right? It's beta. What is the side that I have in this triangle now? The common one, hey, BC. BC over sine of this angle, but do I have this angle? No. Can I find it? Yes, I have the other two. All right. So angle D is equal to, now guys, I'm going to write it slightly differently. I'm not going to say 180 minus alpha minus beta. I'm going to write it like this, and I will explain to you just now why I'm doing that. This is the same as minus alpha minus beta, right? If you were to multiply that minus out. So what I'm doing is I'm just saying it's 180 minus the sum of these two angles. Okay, I'll explain to you now why I'm doing that. What is the reason for this? Angle sum in triangle. Okay, I'm going to fill that in on my picture. Okay, that is that angle there now. Now we can use sine rule, right? We're trying to find D. We have the opposite angle is equal to BC, which we have an expression for, over sine of the opposite angle, which we found now. Okay, so let's write that down. D over sine of the opposite angle, which is beta, is equal to, now guys, don't write K over tan theta yet. That's a bit complicated. Let's just write BC. We can put that We can sub this in at the end, all right? Just say BC over sine of this angle now. I'm just using square brackets there because I have like brackets within the brackets. Let me just draw my line here, then I'll show you that again. Well, guys, what's going to happen to that massive angle then? 180 minus another angle. Can I reduce that? Can I simplify that at all? Do you remember when we did reduction formula in trig last term? 180 minus is in which quadrant? Quadrant 2. So this represents an angle in quadrant 2 because it's 180 minus alpha plus beta. And what is sine in the second quadrant? Positive. So this can actually turn into just sine of alpha plus beta. Right? Remember, that's what we use reduction formula for. To take an angle that is as complicated as this, we write it as 180 minus something. Then we remember that 180 minus is an angle in the second quadrant, and sine in the second quadrant is positive. So we can reduce it by leaving out that 180 minus. Okay, so I'm just going to rewrite this. It's like when we did sine of 180 minus x. That should look more familiar, right? And you will asked to simplify this without the use of a calculator. Then you'll say, okay, 180 minus is in the second quadrant. Sine is positive in the second quadrant, so this is just going to become positive sine x. Right, do we remember that? So that's what I'm doing here, guys. In this case, my x is obviously just a bit more complicated. It's a sum, actually. It's alpha plus beta. And guys, this is why I wrote angle D in this form as 180 minus an angle, all right? Instead of 180 minus alpha minus beta. If you wrote it like that, you wouldn't be able to reduce it with your reduction formula here. Okay, so that's something that you need to remember, please, guys. Maybe highlight this or something. Let's add here so that we can use reduction formula. Yes. We're assuming that it is, yes. But it might not actually be. But yes, we have to assume that for it. Okay, guys, so that's something new. All right. So when you're working in these types of scenarios where there are no values and you have to find an angle of a triangle doing 180 minus, please remember that you must put the other two angles in a bracket like that. Okay, let's quickly make D the subject here. What must I do with the sine beta at the bottom? Multiply it out, right? So D is going to be BC sine beta over sine alpha plus beta. But is that what they said my answer is supposed to be? Let's go back up quickly. The answer is supposed to be this. So we're kind of on the right track, right? We have a sine beta, where there we also have a sine beta at the top. We have a sine alpha plus beta, where here we have a sine alpha plus beta. But what's missing, guys? K over tan theta. And isn't that what BC was equal to? K over tan theta, right? That's what's missing there. So what we're going to do, and this step you actually don't have to write down, but I do need to show it to you so that you understand what I'm doing. You can just slightly change the way in which you're writing this fraction to see if that still makes sense to you. If it makes sense that this line is equal to this line. Like I said, you don't have to write this step down. Okay, I just have to show you why we can just plug this stuff in. Right, do we agree that if you had BC times sine beta, you would get BC sine beta? Over 1 times sine would equal sine. Right, so do we agree that this is the same as that? But what was BC, guys? BC was actually K over tan theta. That's what we calculated in the first step over there. We found an expression for BC. BC is actually K over tan theta. All right, so I have to sub that back in now. Times this whole thing, which is sine beta over sine of alpha plus beta. And what do I do when I'm multiplying fractions? I just multiply the numerators, and then separately I'm going to multiply the denominators. So K times sine beta is just K sine beta. Are we fine with that? That's what you do when you multiply fractions, right? You just multiply those two, and then you multiply those two. Right? And what is tan theta times sine of alpha plus beta? Just those two literally written next to each other, right? So tan theta sine alpha plus beta. And that is what they asked us to get. They said we must show that D is equal to this. The tan was just written at the back, but doesn't matter what order you multiply things in. Okay, 2 times 3 is still 3 times 2. Okay, so you can put the tan in the front, or you can put it at the back if you want, it doesn't matter. Okay. Are we semi-understanding what's going on here? Yes. Hey? No, you don't have to. You can if you want, but you don't have to. All right, guys, I think I don't want to lose you at this point, right, where you're subbing in BC. What you also could have done, which some people insist on doing, but then they struggle with the whole thing. If you want to work with this fraction, you could just put your K over tan theta here, right, because BC is K over tan theta, so you could do that. From this step, you could say that BC is K over tan theta, and it's BC times sine beta, right, at the top. And that is then over sine alpha plus beta. What is that what they asked us to prove? Do we notice that this is a compound fraction? Remember, right at the beginning of the year, I taught you guys what to do if you have a fraction within a fraction. Does anyone remember? You multiply the top and the bottom by the LCD of the smaller fractions. Now we only have one smaller fraction, so what is the denominator of this one? Tan. So I'm going to have to multiply the top by tan theta and the bottom by tan theta. Right, in which case I will get what I'm looking for. Remember, guys, this is all one term. Okay, this is just one term. There's no plus or minus there. So this is one term. So if I'm multiplying this term by tan theta, the tans are going to cancel out. So I will be left with K sine beta over sine alpha plus beta tan theta, which is what they wanted us to get. Okay, so you're more than welcome to do this if you want. Some people just get confused with a fraction within a fraction, but if you are fine with that, then you can use this method. All right, or you could visualize taking the BC out. You can write BC at the front on its own, and then just multiply the numerators and the denominators. It's up to you. Okay, any questions, guys? You're going to practice some of these now, and it is quite difficult to get into it, all right? But this is unfortunately how they usually ask it in test or exam. So we usually have one with values and then one of these, and then we must still do some in circles as well, because we combine those as well. So it's the same exercise, guys. We did number 1.1 together now, so you can just carry on underneath this. This was 1.1. Sorry, I'm actually not going to write this here. So now you're going to do 1.2 and number 2, please. All right, now you're going to do 1.2, which is the next one, and then number 2. I'll put it on the board for you now. Just write that down, please. That is your homework for tomorrow. Yes. Sure. It's exercise 7. We wrote the heading higher up. Okay, you are doing 1.2. We just did this one together. You're doing 1.2 and number 2, please. That is your homework for tomorrow. Get going. Wait for Rania to come back, please. Yes. Yeah. Is that fine for yours? Okay. All right, get going, guys. You have 15 minutes. You can do at least the first one in that time.